Thank you, everybody, for taking your time to join us. I'm Vaughn Stewart. I am the Chief Evangelist for Pure Storage. I'm going to spend a little bit of time with you over the course of the next 45 minutes talking to you about the potentials of flash storage devices within your data center. Specifically, this conversation will focus on core elements within the flash platform. But I want to leave the floor open if there's questions specifically around the VMware or virtualization use cases. And so while we have 45 minutes, if I'm on a slide and a question comes up, just raise your hand. We'll make it very interactive. There's no need to save questions for the end. If we need to table something, I'll ask you to hold off and we can follow up afterwards. So I work at Pure Storage, as I've shared with you. I spent the last 13 years prior to that at NetApp, and then prior to that I was an administrator, systems administrator like many of you. I helped drive NetApp to have second largest market share within the VMware space. And what you see kind of in the state of the union today is that customers are really frustrated with storage. Take technologies out of place, whether it's SAN NAS, take technologies off the table, whether it's vVols or vSAN, things of that nature. No one's happy with storage. And these are a lot of adjectives or descriptive terms that people use when they think of storage. And I should say that, or should add that, to add to the point of the frustration of storage, look at how many storage vendors are downstairs in the sponsor floor. There's opportunity for change. There's technologies that are going to change and drive the market forward. And this is really our vision with flash storage, which is, can I make a simple change as simply changing the storage platform that I run my environment on? And can I receive a 5x increase in performance, a 10x decrease in both power requirements and rack space requirements, and simply make it exponentially easier to operate? So I think the way to start this conversation is to do some basic primers, which is to understand that spinning disks spend the majority of their time seeking to find information and not serving your information. This spinning disk, you can be 15K SAS drive, it can be a 10K fiber channel drive, it can be your 7200 RPM SATA drive. It's all basically the same premise. There's a bunch of activity that goes into serving the process of the disk. This is the slowest element within your data center today. It's the last mechanical device within your data center today. Right? This is the bottleneck for a lot of operations. And as you start to look at what happens with around the rest of the infrastructure built on spinning disks, the increase of CPU, the additional I/O lanes that have resulted, sending more out to storage devices, the I/O blender effect, which is we've now have virtual infrastructures and shared pools of storage. I no longer have a one-to-one mapping between host and its data set itself. In combination with this rotating media, right, I end up having the performance bottlenecks and the challenges that everyone is running into or has been running into over the last couple of years. To be more specific and to put this into VMware terms, in terms that aren't in a slide, I was always surprised with the number of VMware administrators that over the years got caught up with performance or unplanned performance bumps in the road, whether it was LUN level queue depths, whether it was SCSI reservations, file locks, right, elements bound to clustered file systems, pathing issues, right? These are these kind of challenges that have plagued everyone over time, and as a byproduct, you've seen VMware engineering create a number of fantastic technologies that help you deal with when you disk drives and disk-based systems that basically have significant performance restrictions and capabilities. Technologies like SIOC, storage DRS, etc., are all designed around how do I ensure that I never over-tap the spinning disk drive platforms because they frankly run out of performance. So no one challenges the fact that flash media is exponentially faster than disk drives. Everyone also recognizes that flash media is much more expensive than disk drives. And so you see a number of ways of implementing flash into your environment that is focused on reducing the cost, and it's using flash at some form of caching tier, whether it's in the host, whether it's a flash edition inside of the array, or whether it's actually flash as a medium but as a storage tier, right? Some mechanism of moving and shuffling your disks around. The end result of this means of bringing flash in will always improve the performance of your arrays. What is that improvement? percentage, could be as low as 8%, could be as high as 30%. What you don't see is a consistent overall gain in the performance. You don't see an exponential gain in the performance. You see a moderate increase or uptick. You still have the same spinning devices, and you still have this cache hit ratios or reactive elements such as in storage tiering. Our goal at Pure Storage is to make flash available as a complete replacement of disk. And we do that under the focus of being able to provide you flash, an all flash-based storage array at a price point that's less than spinning disk is today. So these are kind of the highlights here, which is we provide a 100% all LMLC based flash storage device at a price point less than disk, which I stated with you. We want your ability to leverage this technology to be as easy as possible. So I use the term plug and play. So supporting elements like vStorage APIs or VAI, having an OpenStack driver, having a RESTful set of APIs for management, but also from a storage management perspective. There's no RAID configurations. There's no tiering, right? There's no spares, right? There's all these classic storage management elements that no longer exist when you're in the spinning media or when you're in the flash media space. So the bottom line is this is to significantly increase your performance while also changing your operational model to make it much more simpler. And then to go back to those elements that I shared with you before that are the tiering factors, the SIOC, the storage DRS, and really significantly reduce your reliance on any of those tools because I'm chock full of performance. And so as a starting point, right, the Pure Storage platform or the flash array is a symmetric active-active array. It can deliver up to 400,000 IOPS of performance. It's available to do this for you with an average latency of less than 1 millisecond. It can do this over 8 I/O ports, which can be a combination of fiber channel or gigabit Ethernet. This is either fiber channel or iSCSI for access for your data stores. We support a 35 terabyte configuration of raw media today, and all the data is encrypted at rest. It's 100% encrypted. This leveraging our storage efficiency technologies means that in 10 rack units, that's 2 controllers and 3 shelves, I can have up to 175 terabytes of addressable storage. That's a common configuration within a VMware server virtualization environment. So I would actually pause on this, and maybe I need a different set of slides, and I'm thinking about this on the fly. Pause and think about how this impacts your environment. I can move 400,000 IOPS in a space that's about this large. That 400,000, this space can provide me 175 terabytes of usable configuration. How much rack space do I free up if I move this from spinning disk? What is my power reduction? Our boxes generate 5,000 BTU per hour. By contrast, an 8-engine VMAX system generates 150,000 BTU per hour. I can reduce the heat that's being created in your data center, thus reduce the power that's required to cool your data center, thus provide you more power to run servers and storage. My storage runs on 110 amp or 110 volt circuits, not 220 volt. So now I can double the number of actual physical power outlets that I can have in my data center and power more devices. And the rack density through the storage savings means I can store more. The end result of this flash movement is I can actually allow the data center to scale the amount of data that it can store and serve relative to what's in a spinning media game. So I bring this up because most of the times when we talk flash, people think it's just performance. Performance is a given, right? Jen's here, my good friend. He's from Violin Memory, right? We can benchmark, or bench test the performance of a Violin Memory box or the Pure Storage array versus some other all-flash array. What you're going to find is in most use cases, you're hard-pressed to find a performance difference. You can't tap out the 400,000 IOPS I put in the box. But what I can do for you is make your applications run 5 times faster without you having to do anything to the application. So let's talk about this a little bit in depth. The primary element of what we are bringing to bear is I have to eliminate the price hurdle of flash. And we do that through a combination of storage technologies. We are the only storage vendor in the industry that combines a 512 byte block size, which means no more misalignment of virtual machines, as well as the ability to deduplicate across aligned and misaligned virtual machines. I can do a data reduction with data deduplication. I can amplify that with a data reduction through compression. I also do thin provisioning, and I do what's called pattern removal, which is if you're formatting a set of disks or you're sending a stream to me of the same blocks, the system just automatically tracks those and ignores those. So you could kind of think of that in a way of data deduplication. On our website, we have a data deduplication tracker. We average across every customer and every data set size a 6-to-1 storage reduction element. So think of 6-to-1. The way to think about 6-to-1 storage savings is there's no value to you in storage savings. Let's be very clear. No value to you who runs and operates the environment. The value to you is that is their cost reduction multiplier. For every terabyte we're shipping to customers, we're on average giving them 6 terabytes of capacity through the storage savings, right? It's a cost reduction mechanism. When you add thin provisioning, which we don't track, you actually get just under 13-to-1 savings. So 6-to-1 is actual data stored on the device. We don't track thin provisioning because thin provisioning is just something you've provisioned but you haven't used yet, right? So you're carving out big LUNs that are empty. There's no point in measuring that savings. So I'll give you a little bit of detail, further detail here. This is actual data from our systems that report home. This horizontal axis shows you buckets 2-to-1, 3-to-1, all the way up to where we get to 9-to-1, 10-to-15, 15-to-20, 20-to-1. The gray bar is the number of systems that are deployed that are receiving these results. And these vertical bars show you the combination of storage savings technologies. Orange is compression, blue is data deduplication. So this is representative of our entire customer base. This is all production data. Again, no thin provisioning. What you can see here is that the bulk of our systems receive somewhere between 4-to-1 and 7-to-1 data reduction by and large. At the low end of the spectrum, you see databases and applications like analytics and technologies of that nature, typically between a 2-to-1 and 4-to-1 storage savings ratio. In the middle, where I'm labeling virtual infrastructure, is where data deduplication starts to drive more savings involved, and you start to have data deduplication eliminating the redundancy within your operating system images and your binary sets, and compression reducing the working set size of the applications inside of those VMs. That's giving you this 5-to-1 to 9-to-1 range. In this uber high, where you start to get somewhere between 10-to-1 and greater than 20-to-1, this is when you start to have a ton of redundancy. So this would be like virtual desktop infrastructures or database environments where you have lots of copies, such as test and development or SAP, things of this nature. So again, apps that are virtualized, and then high levels of redundancy, test and dev, virtual desktops. The bottom line here is that the storage savings common technologies that I shared with you earlier is what makes this all-flash prospects affordable and allows us to basically offer systems today that on a price per usable gigabyte are less than spinning disk. As you can see here, we're going to continue to drive this price point down. That's our plan as we make the systems denser and larger, as well as the price point of flash continues to drop. This is our stated goal. Now, I have focused on, so far in this presentation, that we're all flash. I haven't been highlighting performance because I think flash performance should be understood as a given. Again, if we want to have those conversations, ask and we can respond to those. So far, I've been focusing on the price element to drive down the cost and the adoption, but that's not the only element that you have to consider when you're looking at storage. You'll recall I stated that storage needs to be plug and play compatible. It needs to be a simpler model. This card that I pulled out of my pocket is the same card that you can find at our stand on the Solutions Expo floor. It's about the size of a business card, and it kind of folds and it opens up. For those of you who prefer command line, this card front and back shows you every command line option available on the array. There aren't any more. This is not a subset. This is it. Right? I'd actually ask most of you to actually use our GUI. So if you start to look at what's on the screen here, in the far left box under resiliency, the devices doesn't have a root volume, doesn't have aggregates, doesn't have RAID sets, You can't tune the data deduplication or compression, right? There's logic in the box that sets this all up. So when you power on the box, it requires 3 IP addresses. One for your management, one for your monitoring, and one so that you can provide us remote access in if you had a support ticket opened. The box is a pool of storage. There are no spares. There's no RAID to configure. You just fire it up and start provisioning LUNs to your hosts. We use a technology called RAID 3D. It survives a double disk failure. When a disk fails, the RAID does not go into a degraded state waiting for a spare to be returned. It automatically self-heals based on free space capacity within the array. It looks at a failed drive as a reduction of capacity, not as a failed media waiting for another drive to be put in. It's the same logic we use when you expand capacity by putting in new drives, right? It just automatically grows. It's also adaptive. And what that means is, if you have a data set that has a high level of deduplication or compression on it, it interprets that as being used by a larger number of systems externally, and it will go ahead and make nth parity bits. It will increase the redundancy on that data set, understanding that that data set is more critical than the rest. We have zero copy snapshots, which means they're immediately available and only consume new blocks as they're created. Some of you who have used technologies like FlexClone from NetApp may understand how that works very well. We also do snapshot-based backup copies, and we've just released replication into beta for our customers. All of these storage-based features that I've shared with you are provided at zero cost. They are included in the storage technology itself. So there are no add-on price points as you continue on or want to add more features to the box. The second area is in the area of manageability. I stated this earlier, which is we have a complete set of RESTful APIs for management. We have a Grizzly OpenStack driver with the Havana driver and then a richer set of features targeted for Q1 of next calendar year. We support all the vStorage APIs today with the exception of the thin provision threshold warning message. And we have a web GUI. Was that our hand that came up? Okay. So unified storage platform from a perspective of we support block-based storage protocol access either over Fibre Channel or iSCSI, depending on what fits and suits your environment. We support iSCSI CHAP. That's a new feature that we've recently released. And from a security standpoint, fully integrated within the AD and LDAP. As I stated earlier, all data is encrypted on the devices. And we provide support for syslog servers for monitoring and management. And we have a Splunk app in development that, again, should be targeted for Q1 release. Our Q1 timeframe, we're looking at releasing the Purity Operating Environment version 4.0. We're currently on 3.3. With the 4.0, we'll be adding these feature sets along with a SRA for VMware vSphere. In addition, you can see in the bottom part of the screen all the operating systems and applications that we're certified with, ranging from VMware, Microsoft, Citrix, into the Oracle stack, Semantic Technologies, etc. I want to share with you 2 other points, and I'm watching my timer. I think I'm going really fast. When you shift from spinning disk arrays that service tens of thousands of IOPS to flash-based arrays which serve hundreds of thousands of IOPS, you have to think about your architecture a little bit differently. Anyone here ever have a active array controller where you've had one side fail or you've had to do maintenance and then performance suffers while you've got one controller down? Anybody a NetApp customer or anything like that? Right. When you have an array that's serving maybe 30 or 50,000 IOPS and performance gets cut in half, that's a bad day. When you have an array that's serving hundreds of thousands of IOPS, you can't have performance fall in half. That's catastrophic to a business. So one of the things that we designed into the platform is this construct called NonDisruptive Everything. And the primary element that enables that technology is that we limit the performance of the controllers. So there's 2 controllers in a system. We limit the performance through software to that of one controller. So in other words, maximum performance is not maximum on the hardware. It's software limited to what it would be in a failover event. So the benefit of this is it allows you to complete hardware expansions non-disruptively, software upgrades non-disruptively, but more importantly, is to never have to replace that system from a logical perspective. I can go through hardware generation upgrades without ever disrupting the working set. So we've had customers who have tweeted photographs as they've gone through the upgrade process where they've had their controllers, one head on a 300 series and the new head on a 400 series, right, still serving hundreds of thousands of IAPS at sub 1 millisecond latency and never having a drop in terms of application performance or any interruptions from the hosts. This is the design that is based off when you can actually limit the performance to that of one controller. You can do a lot of things around at the management layer. Question? So, in addition to this, we've introduced a new support and management model. So obviously there's been this big focus on simplicity, right? We talked about all the storage elements that have been removed. Is one of the strengths in our product is at the support layer in what we call cloud assist, or what you could generically state as phone home. A cloud assist element is our boxes report back to us on 30-second intervals and report back immediately upon an error or failure. What this allows us to have is a rich and deep set of information that's going on within the controller that we can mine. We can mine and provide near real-time monitoring. So we're looking at things every 30 seconds. Obviously, a real-time event would cause an immediate response to us. But this near real-time monitoring allows us to have a better understanding of what's going on in the box. We're not looking back at something that happened between last week's reporting and the current event and parsing through tons of logs. We can look from a very granular perspective, be more proactive. We can also provide run a number of analysis on this data and start to look at trends across the user base and understand if we have to refine things in code or proactively reach out to customers so we can help ensure the best possible environment from an operation perspective. It allows us to be much more proactive and again allows us to continue to refine and improve on the product portfolio or the product platform itself. So this is kind of where I'm at within the presentation. I've stuck in a demo here that I'd like to share with you a bit just to explain and show a couple of these elements in action. I just got to make sure it runs. And it didn't. So let me make sure I can get it to go here. Here we go. Where's my play button? There it is. So this is our OpenStack driver in Folsom. I may have said Grizzly earlier, it was Folsom. So this is our OpenStack driver. This is what I showed at VMworld. So I don't know how many of you here have looked at cloud automation. You can do the very similar things with VCAC as well, vCloud Automation Center, or OpenStack, or CloudStack, whatever your preferred method is. What I'm creating here is a boot volume, which in VMware terms means a virtual disk, a VMDK, right? OpenStack uses some different terms than in vSphere. And what I'm picking is to clone this from a host, and then I'm going to go ahead and actually connect that to a predefined instance. An instance would be called a VM template, compute, memory requirements, network configuration. We've actually just switched over here to show you that, and it went by a little quick. Show you that in command line. I'll rewind that here. Just because there's always some element of the customer base that likes command line. So we listed our instances, and we went ahead and attached it. And we're actually going to boot that system. So we flip into vCenter here, and gosh darn it, that's moving really fast. I'll rewind again. And we can see that instance running on the left at CR01. And now we're flipping over to our management interface within the Pure Storage array. Golly, it's going faster than I can talk. I'm going to start pausing this. Pause. What you can see is on the array, we already have some load going on. Got about 190 megabytes a second, 24,000 IOPS at 4.45 milliseconds latency. Some other items of neat note here, as you can see, I got a 22.7 to 1 data reduction. Understand that's really high because I have a lab, right? We make lots of the same virtual machines over and over again. Not indicative of a real-world virtual infrastructure environment. And what you can see, besides these graphs of the IOPS bandwidth and latencies over on the left, I've got a little display of the controllers and the 2 drive shelves. That would be kind of the upper left corner there. I'm pointing that out because you're going to notice some activity over there in a moment. Now, back to our demo. The reason I'm showing you that I've just cloned a virtual machine and that I have a running state, and I'm going to, golly. the reason that I'm showing you this, and I got to really watch when I hit pause, is that one of the things that we learned through the adoption of server virtualization, and whether we want to call it cloud, private or public, is that your ability to control your infrastructure has changed. You used to have finite control over your servers. I gave these LANs, whether they were local disk or they were in a SAN, I gave it to this host. I understood where the partition boundaries were. I could adjust the partition block size to match that of the application, right? I could fine tune and control it for optimal environmentals, right? And that's how we ran our infrastructure. Of course, we always over provisioned and we always bought us buffer room, right, and all that stuff. And server virtualization kind of came in and said, hey, you were spending a lot of money on that over provisioning. Let's get more efficient. Let's make things dense. Let's gain a bunch of new features around availability and mobility, right? We'll get this through virtualization. And we all did this. And what we learned was we ended up giving up control of what was occurring in the VM, right? If I manage an infrastructure, I can give you CPU, I can give you memory, I can put you on different tiers of disk, but I lose control of what's going in that VM quite often. I don't know where the partition boundaries are. I don't know what the block size of the application is. If someone's taking snapshots or doing something in the app, right? I don't know what this is. And if a VM deployed a couple years ago runs out of memory and the application starts successively paging and swapping, right? I start increasing disk drive load, right? I've got all these elements that I have no control over anymore. And I'm trying to figure out what they are. And I'm trying to find tools to figure out what they are. The reason why I explain this or create this scenario for you is this shouldn't be foreign to many of you. These are issues that storage vendors have dealt with over the years. Customers deal with. And the reason I bring it up relative to flash is we're at a point in time that flash allows you to have a more resilient infrastructure. It allows you to maintain steady state while you're losing control of what's going on in the application, while you're losing control of what's going on in the front end. And so I cloned a VM, and I showed you I.O. running. I want to show you, and I'm going to continue to make more I.O. load on the system because I don't know what's going on in these VMs, and I have to have a platform that can sustain change. So the one VM that's creating this workload for me is made from this template, and I'm going to go ahead and create 2 more and clone from template. Now this is, I forget the size of the VM. It may say over there, 20 gig is what I think it said. I'm going to clone these, put them in some data stores. Sorry I didn't take some of the time out of this. And this is going to be obviously offloaded through vStorage APIs. It's an eager 0 thick VMDK, so it's actually cloning the full 20 gig. So we went off and made one. We're going to make a second one here. And these VMs, when they boot, they actually just start running iometer, right? So roughly 30 seconds or so for them to boot, and you'll see the load appear on the array. So I'm sure we've all seen this provisioning wizard a couple times, and it'll change here in a second. So part of my conversation was flash gives you performance. Part of my conversation was flash reduces your cost. Part is it gives you simplicity. Part of the operational peace of mind that you can get is available not just through non-disruptive upgrades. It's how do I just keep serving my workload when I don't know what's going on? And what you'll see here is I was basically at 190 megabytes a second earlier. I'm now in the 300 range. I was at 24,000 IOPS. I'm now at 41. And I was at 0.45 milliseconds, and I'm now at 0.55. And this workload is going to continue to increase here a bit as the machines continue to run. Now, what you don't see is at this point in time, I've got someone who's going to go run in the lab, and they're going to start pulling disk drives. And you should see them start to light up red over on the other side. And again, as you can see, my load continued to increase. I just hit 400 megabytes a second here a moment ago. You see one of the drives that failed. But you see no change in the workload. And at this point in time, I'm now telling the person in the lab to go pull another drive. And you'll see that change red in a minute. And again, no surprise, is you won't see a change in the workload either. This is the type of non-disruptive elements that I've shared with you that we have built in the system. Now, the next big one is I'm going to tell them to pull a controller so that I can substantiate to you what I shared with you from a performance standpoint. So you'll notice when the controls will go red. It happened to be the controller that I was connected to for the management console, so it'll take a few seconds for the management console to refresh. You see it just went white here. Controller's red. My graphs will come back here in a moment. And you'll notice again, my workload is still in line with what I was serving. I spiked a little bit for a second. I hit 1.01 milliseconds, but I'm still being very consistent when I'm delivering. These are elements that I share with you from a, how do I make my environment more resilient and in running this cloud infrastructure. So I hope that was somewhat impressive, some of you. So coming back to who we are with Pure Storage. We are the fastest growing storage company today. We are in our 4th year. We just passed our 4-year anniversary. We are on version 3.3 of our code with version 4 targeted for release at the end of Q4 next calendar year. I started 12 weeks ago when we had 200 employees. We're nearing 400. That's the rate at which we're growing. In January, in the 2nd week of January, we will open our Amsterdam office as well as our London office. In the 3rd week of January, we will open 2 offices in Germany. And in October, I helped open the Melbourne and Sydney office, and about 8 weeks ago, I helped open the Korea office. So we're continuing to grow our presence globally. We are currently at a run rate of 60% of our customers are making a repeat purchase within their first 90 days. This is the type of devices that are coming in and helping customers have exceptional gains within their infrastructure. And to that point, we are the only storage vendor that is guaranteeing that if we can't deliver on what we say to you, we will give you 30 days to allow you to return your box, no questions asked. Obviously, we'll work with you and work with you through our partners to make you successful. We want happy customers. But if for any reason you don't like it, including you just say, I'm not a fan of the color orange and I can't stand to look at it on my bezel, put it back in the box. By the way, I love orange. I see the world through orange colored glasses. But so the last element that I will share with you is we target flash to replace spinning disk, your performance-based spinning disk, 10,000 or 15,000 RPM. That's a $15 billion a year business market, and we believe that that whole market could be eliminated within the course of the next 5 years. Performance is solved. It's inherent within the flash media itself. The real difference is how do you reduce the cost, which we've covered, I think, hopefully in depth, add resiliency, usability, and supportability to the platform, and that's all delivered within the software piece. So this is our credo, which is to drive flash for all. I think we've got just under 10 minutes left, so I can take some Q&A. I will share with you one last point, which in hindsight I wish I would have put in my deck, but you can read about it on my blog, virtualstorageguy.com, is to give you an example of the impact of this technology and how it moves things forward, is I share a story with a customer, and I can't share their name, but they're a global insurance company who had a SaaS business analytics application. And it ran on a 6-engine VMAX that had 1,193 hard drives and a 95.5 config, meaning 95% of them were 15,000 RPM SAS drives, 5% of them were solid-state SLC drives used for cache tiering. The SaaS application, the big measurement was the SaaS application had a report that had to run at the end of the month that took 19 hours to complete, and they had to run 11 iterations of it. So basically it took 2 weeks to close out a month. So the customer's goal was to reduce time. That config took 7.5 floor tiles. And to be clear on that is that the 6-engine unit is 24 inches wide, and the disk drive cabinets are 30 inches wide, so they're wider than a floor tile. So 7+ floor tiles of space. We replaced that with 8U. And we went from a 7-figure config to a 6-figure config. Okay, so financially, you understand the impact. From a rack space perspective, you understand the impact, power, cooling. But remember, it was 19 hours for the operation to run. We reduced that to 43 minutes. So now they took what took 2 weeks to close the business, took 1 day, and they had additional benefits, which was no matter which metric you measured, the time to complete an operation was exponentially cut. More importantly, the number of queries that the data scientists were able to run went from 6 concurrent to 200 concurrent, and the 200 was just an arbitrary number that they picked. They really don't know what their height, where they would actually cut off doing that type of work. So again, performance, rack space, data center power, cooling. It doesn't matter which axis you want to measure this on. This is the type of change that all flash can drive in the infrastructure. So with that said, 5 minutes. Any questions, thoughts, comments? Really? Come on. What color's my wallet? That'd be a good question. It's blue. There. Nothing? All right, then for a quick show of hands. Anybody got all flash array in their environment today? You don't get to raise your hand. No? Anybody have a hybrid array? Okay. Anybody here not having storage problems? That's probably a better question. Shut up. Okay, well, I'll be around if there's questions. Thank you for your time. I know my pace at first was a little fast. You guys make me nervous. But thanks.